Hi students, this is Allied Physics class. I am your professor Dr. D. Silambarasan. In the unit of relativity, we are going to see Lorentz transformation. Before going into the Lorentz transformation, I just want to reclass, that is we learnt in class. In this unit, we initially saw about theory of relativity, and after that frame of reference. Frame of reference is nothing but a set of coordinates which represent the position of any object. It is classified into two types. One is inertial frame of reference, another one is non-inertial frame of reference. Inertial frame of reference, there is no acceleration of object or medium, so it has the constant velocity. It obeys the laws of physics. In non-inertial frame, basically it is named as accelerating frame, though the velocity changes continuously. Here the laws of physics does not valid. After that, we have seen the Einstein's postulates. The important postulate is that the velocity of light is constant. Before going to Lorentz transformation, first we have to know what is transformation. Transformation is it's just a transformation of a set of coordinates from one reference frame to another reference frame to know the coordinates of any object. Right, Lorentz transformation. In this transformation, we have to consider an object moving with a constant velocity v with respect to frame S along the positive x direction. Initially, we have to consider two frame. One is S frame, another one is S prime frame. Its origin is O, and its origin is O prime, and the coordinates are x, y, z, and here x prime, y prime, z prime. Initially, these two coincides. These two frames are coincides, and consider this frame is moving with a constant velocity v. We consider a random point P, and we have to transform the coordinates from here to here. So we know that the velocity is constant. So we can write as the displacement x is equal to v by t. X is distance or displacement, v is velocity, and t is time. This comes from the basic definition of velocity is equal to distance travelled by time. V is equal to dx by dt. So v is equal to x by t, x is equal to v by t. And we consider two observers at the origins O and O prime. So we can write the position in the frame S, x square plus y square plus z square is equal to c square t square, and in S prime frame, x prime square plus y prime square plus z prime square is equal to c square t prime square. So we assume that motion is only along the x direction. So the other direction, y prime is equal to y and z prime is equal to z. We named these equations 1, 2 and 3. Equation 1 minus 2 gives, this is equation 1, this is equation 2. After equating y prime is equal to y and z prime is equal to z, these two terms get cancelled. So remaining x square is equal to equation 1, x square is equal to c square t square, and x prime square is equal to c square t prime square. So equation 1 minus 2. So x square, we bring this term to the left hand side. So x square minus c square t square, and this term we bring to the left hand side, x prime square minus c square t prime square. This is after equating. Now the Galilean transformation is x prime is equal to k into x minus vt, where k is a constant. In the frame S, the relation between x and x prime is given by x is equal to k into x prime plus vt prime. This Galilean transformation we have taken directly to solve the Lorentz transformation. Right, these two equations are named as 4, 5 and 6. Right, substitute the x prime from equation 5 in equation 6. So this we have to substitute this x prime here. So x is equal to k into x prime in the place of x prime. We have to submit k. We have to substitute k into x minus vt. So here x is equal to k into x minus vt plus vt prime. So multiply this k inside. So kx minus kvt plus Vt prime, and multiply this k inside. So k square x minus k square Vt plus k Vt prime, and bring this k square x to the left hand side and k square Vt to the left hand side. So minus here plus remains k Vt prime remains here. So take take the x common. So x common 1 minus k square plus k square Vt is equal to k Vt prime, and bring this kv to the denominator. So kv here. So x separate these terms. So x into 1 minus k square by kv plus k square Vt by kv is equal to t prime. Here 1k get cancelled and v get cancelled. So this yield x into 1 minus k square by kv plus kt is equal to t prime. So equation, we know that the equation 4 gives x square minus c square t square is equal to x prime square minus c square t prime square. Substitute x prime from equation 5 and t prime from equation 7 in equation 4. So in equation 4, left hand side is x square minus c square t square. Right hand side x prime is k square into x minus vt square minus c square. T prime we have derived here. So t prime we have to substitute x into 1 minus k square by kv plus kt square. This we have to expand as a minus b whole square. Here a is equal to x, b is equal to vt. This is in the form of a plus b whole square. So here also we have to expand. This term is a and this term is b. So left hand side right. So k square, here a square x square plus b square v square t square minus 2ab 2x vt minus c square. This term is a. So a square means x square 1 minus k square whole square divided by k square v square plus b square plus k square t square plus 2ab 2 times x into 1 minus k square by kv into kt. This k get cancelled. Now we have to compare the coefficients of x square on both the sides. So here x square and here k square into x square and here c square into x square. So in the left hand side there is only one term, right hand side here one term and here one term. We have to compare the coefficients of this term. So x square, the coefficient is 1. Here the coefficient of x square is k square, and here the coefficient of x square is minus c square 1 minus k square whole square divided by k square v square. Bring this k square to the left hand side. 1 minus k square is equal to minus c square 1 minus k square whole square by k square v square.